Hello everyone. In this video, you will learn how the MicroBlaze processor handles interrupts. You will be shown how to set up the interrupt controller in Vivato's block diagram. After the block diagram is complete, we will demonstrate a real-time example of a push button triggering an interrupt on the MicroBlaze processor. So to start, let's explain how the demonstration will work. First, you will press and release the button, which will produce a noisy signal. The noisy signal enters the Button Debouncer IP, which generates a clean, single-cycle pulse on the falling edge. The pulse enters the interrupt controller, which sends an interrupt signal to the MicroBlaze processor. Each time the processor receives an interrupt, it toggles the LED and prints the total interrupt count through UART. So in this demonstration, there are 4 main IP blocks to add. The first is the Button Debouncer IP block. This IP block is a custom Verilog module that we created in the Button Debouncer video. This Verilog module debounces noisy button presses by converting each noisy button signal into a clean single-cycle pulse. I highly recommend watching the Button Debouncer video before watching this video. The second is the interrupt controller. This block receives the pulse from the debouncer and sends an interrupt to the MicroBlaze processor. Its default settings are sufficient because the IP block updates automatically. The third is the GPIO block. This allows the processor to control the LED through AXI for light write commands. For this demonstration, configure it as a 1-bit output. The final block is the UART block. This allows the processor to print the interrupt count to the serial terminal. Its default settings are sufficient. To help reinforce the flow of making a block design, I will create the entire project from scratch, build the block diagram, generate the bitstream, export the hardware, and run the demonstration code in Vitis, all for you to see. So, start by making a new project. Give your project a name. Add in the constraints file. And then select your board. I'm using the Nexus 4 DDR board, so that is the one I must choose. Then add in the MicroBlaze processor, the clocking wizard, the GPIO block, the UART block, and the interrupt controller. After that, configure the settings for each block, run block automation, and organize the layout. We still need to add in the Button Debouncer IP. Since this is a custom piece of Verilog that we wrote, it will not show up in the IP catalog automatically. To make it appear, we first need to save the Verilog file in a dedicated folder. This is the folder that I am using. Then, we need to package it as an IP in Vivado. When packaging the IP, navigate to the folder where you saved the Verilog file. After the IP has been packaged, it will appear in the IP catalog, and we can add it to the design. After adding it to the design, finish the connections and validate the design. The GPIO block settings are wrong because the block automation chose the wrong settings. To fix it, delete the block and choose the right settings. When the design was validated, one critical warning came up. This is because the block automation configured the UART block wrong. Go into the UART block and fix the mistake. Once the design has been validated with no errors, add the constraints file from the provided project files. After the constraint file has been added, generate the HDL wrapper and then generate the bitstream. Once the bitstream is complete, export the hardware to a known folder, program the device, and launch the Vitis IDE. Before launching the Vitis IDE, choose an empty folder for your project workspace. This is the folder that I will be using. After choosing that folder, launch the IDE. Create a new application project. Then navigate to the folder where you exported the hardware and select the XSA file. Give the project a name and then create an empty application project. Next, create a new source file for the demonstration code. After creating the main source file, paste in the demonstration code from the provided project files. Then, click the hammer icon to build the project. After the project has been built, open the Vitis serial terminal and connect it to the board. Next, create a new run configuration. Uncheck Program FPGA, click Apply, and then run the application. The demonstration code will now be loaded onto the MicroBlaze system. After the code has been loaded, we can press and release the button to see whether the interrupt is working. Each time we do this, the LED toggles and the interrupt count is printed in the serial terminal. From this, we can clearly see that the interrupt is behaving exactly as intended. Alright, so if you have made it this far into the video, you should now feel confident adding an interrupt that comes from nearly any source. While we used a button in this video, the interrupt could have also come from a custom Verilog module, a peripheral, a slide switch, or another source in your design. Alright, that's all for this video. Thanks for watching, and I look forward to seeing you in the next one.